So this is the more traditional proved trig identities. Remember, for a week or two there, you had some unusual ones that was kind of new to the curriculum that had more to do with cofunctions and odd-even functions. These, I looked at them briefly. They're going to have to do more with your traditional 11 identities, although you do have to know odd-even in this also. But let's start with cosecant. Is that a plus?
It's multiplication.
Multiplied by cosine equals cotangent. Now, one thing I do when I'm doing these is I leave off the theta, just because I don't want to write it a million times.
All right.
And it's theta, 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 theta everywhere. So, how do I prove these two are the same?
You could make cosecant just sine, or 1 over...
1 over sine.
Yeah.
Times cosine, and now what?
And then if you just multiply, or if you multiply those together, just cosine over sine.
That's the same thing as cotangent.
Yeah.
That's always what you want, is their final line to be the same. And in general, you only want to mess with one side of the equation. It's not an absolute rule for proving identities, but notice the only purpose of identities is really to get you to learn your identities. There's no real other reason why we would ever have to prove these identities. Now, there are trig equations that need to be solved sometimes, and you need to use trig identities. That's a different story. But, so what are we going to do here?
So you just it would be 1 over cosine.
And then that's the same as sine over cosine. And that's the same as tangent. That's kind of the way I do them, like that.
Okay.
In other words, I work with the left side until I make it look like the right side. These are actually kind of fun if you really are good at your trig identities. They can be challenging because it's really easy to go off in the wrong direction. And sometimes when you go off in the wrong direction, you just kind of get lost in the woods and you don't ever get to your destination. This time I'm going to write theta because it kind of matters here. What are we going to do here?
Wouldn't you make, so it would be 1 minus tangent squared, wouldn't it?
Yeah, in other words, let's do this in a couple of steps. First of all, what this is tangent of minus theta times tangent of minus theta. That's what that means. Okay?
Yep.
What is tangent of minus theta equal to?
It would be equal to negative tangent.
Right. In other words, it is an odd function. So therefore, I can turn it into that. Same thing there. And now, multiply everything out. What do you have on the left side?
It would just be tangent. 1 plus.
Tangent squared of theta. Well, that's one of our trig identities. In other words, that on the left is equal to secant squared theta.
Okay.
Okay? the format where they give you an odd one and then they give you an even one that's basically the same as the odd one. How am I going to rewrite number 4?
It would just be 1 plus cotangent squared.
For exactly the same reason as the previous problem. In other words, cotangent is also odd, same as tangent. And that means that when I have cotangent negative theta, it's negative cotangent of theta. And you end up, that's what you have. And that is our third Pythagorean identity. In other words, the left side is equal to that. Notice, let me just reinforce this. This is the second identity, Pythagorean identity.
Yeah.
Well, that's the only one you have to memorize, because the third one is merely the cofunction of that and the cofunction of that. In other words, cotangent is the cofunction of tangent, and cosecant is the cofunction of secant. So as long as you have the second one memorized, you can always figure out the third one.
All right.
In trig, the less you have to memorize, the better. In other words, if you can get away with memorizing 9 things instead of 11, you want to do it. Because there's so much to memorize. In other words, if you can always figure out stuff, that's better than memorizing it. As you've probably figured out, one almost foolproof method of doing these is to convert everything to sines and cosines, including this one. In other words, we only have one cosine, but I can turn that into sines and cosines, I can turn that into sines and cosines, and I can turn that into sines and cosines.
So I should change whatever side I'm not using to?
Well, work on the more complicated side. We don't need to change the right side yet. Just know that what we want to come down to on the left side better be this. Once we come down to that, we'll have it solved. So let's start.
So it's cosine theta and then sine over cosine. And then plus cosine plus sine.
Cosine over sine.
Yeah.
Okay. Multiply out, what do you have?
It would be sine over sine cosine. Then
Sine theta plus cosine squared theta over sine.
Yeah.
Okay, and somehow that's going to be equal to cosecant of theta. Well, remember what I said our goal was on the bottom? We're going to end up wanting this. What's the next step? If this is what I finally want at the end, what's the next step?
Is the sine theta over cosine theta? Or
add these two fractions together.
So
what's the common denominator?
It would be sine.
What goes here?
sine squared.
And what goes, I didn't have to do anything
Cosine.
to that side. What's sine squared plus cosine squared equal to?
1.
That's what the left goes to.
All right.
So if you get stuck on some of these proving trig identities, just do the algebra. In other words, it wasn't really clear what we needed to do there, but the one thing we could certainly do is add sine theta to cosine squared over sine theta. And when I mean add it, I mean find a common denominator and go from there.
All right.
Boy, they're not terribly creative. But that's okay. This is probably good practice for you.
Yeah, it's from the book, so.
No, I know. I even know the book. And yeah, they do this throughout the whole book. It's not a bad idea, especially if somebody's working with a tutor, because the tutor can do the odd numbers and then the student can do the even numbers. So what do I want as my last step here?
You want 1 over cosine.
Probably. Okay, so let's proceed. What's this become?
Cosine over sine.
And this?
Sine over cosine.
See, that's exactly what happens, is by the time you're done with this, you're going to be really good at these. Next line?
It would be cosine plus sine squared over cosine.
Next line?
It would be cosine squared plus sine squared over cosine.
And next line?
It would just be 1 over cosine.
Correct.
All right.
Yeah, I shouldn't criticize, actually. I kind of like that, to be honest with you. As a tutor, the best thing you can do is always have the student do a problem similar to the one you just showed them how to do. Okay? What about here?
Yep. So wouldn't it just be, wouldn't you get, it would be sine over cosine and cosine over sine.
Okay.
So those just cross out to equal 1 minus cosine.
Good. So we have 1 minus cosine squared equals sine squared. Now what?
And then, isn't that more or less one of the
Yes, it is.
Pythagorean?
Not even more or less. That is one of the identities. In other words, it's rare you're going to see it like this.
Okay.
It's much more common that you're going to see it like this. Or like this. So learn to recognize that that is sine squared and that is cosine squared.
All right.
Okay? I mean, you're always going to recognize that that's 1, but recognizing that that is sine squared is a little harder. You got to do the algebra. In other words, if you take your original identity and solve for sine squared, you get 1 minus cosine squared.
All right.
This one?
So it's sine.
What should this end up being based on the last problem?
It should end up being 1.
Okay, is it?
Yeah, because Isn't it just sine over sine?
Right? So that problem is the same as the last problem. All right, I'm going to go to my book and give you a few more here since we have 15 minutes left.
Yeah, our homework is to 16, but I didn't, my phone was being stupid.
Oh, okay. Let me see if I can find the page.
It's page 190.
Yeah, in my book it's going to be different, unfortunately.
Chapter 3.
I thought we had the same book, but we don't. Identities. Let's see, what did you start with here? Start with cosecant plus cosine. I don't see that in my book anywhere, but I've got plenty that we can do. And I don't think there's any particular magic in one set over another. Yeah, hold on. Yeah, just a second. Proving trig identities. This is what I want. Okay. In fact, this might be the same. What did you start out with here? You started out with cosecant times cosine. Okay. No, I don't have that. Good. It's better. Let me give you some fresh ones that depend on other stuff. Prove the identity. And again, I'm going to leave off the theta just in the interest of doing it more quickly or not having to write as much.
Well, I want to do some prep work.
Go ahead.
So, would you just make it cosine parentheses sine over cosine?
Yeah, in other words, here we're looking, we already got a cosine, we already got a sine, we got a sine, we got a cosine. Let's just turn everything into cosine and sine and simplify. That's got to be the way to go. Okay? Remember the purpose of these. The purpose of these is merely to get you to know your trig identities. What next?
So, wouldn't it be sine plus cosine?
Yeah, that cancels with that. Cosine times cosine is cosine squared. Okay? There's nothing wrong with looking over there to see what you're trying to turn it into. It can frequently make it a little faster. If you know what I'm saying.
Yeah.
Okay. And now, the moment you see tan squared, you should say, well, maybe I'm not going to turn everything into sines and cosines here. Notice that I don't have any to start with. Also notice that I have a trig identity that involves tan squared. 1 plus tan squared. So I could go the route of turning it into sines and cosines, but it might not be the best way to go. Okay. Which is the more complicated side? They're equally complicated.
Yeah.
You can make an argument that the right side is more complicated. But this book, it tends to, you fool with the left side, okay? Well, what can we do here?
You can.
What should I turn tan squared into? Here's your identity. Tan squared plus 1 equals secant squared. So either I can mess with the right side and turn that into tan squared plus 1, or I can mess with the left side and turn that into secant squared minus 1.
All right.
That's what I would do. Let's just keep messing with the left side. So I have 1 minus the quantity secant squared minus 1. Gosh, did I read the right problem here?
Yeah, I don't see how that's possible.
Very good. Very good pickup. Oh, this is what it is. That's pretty good. You got very quickly to the point where you proved in your head that it could not be an identity. Okay, what's my first step here?
Can't you just, so if you square everything, it's 1.
Well, you don't have to square everything, but squaring that is
foil.
the proper thing to do.
Yeah, you foil.
Exactly. It's 1 minus tan x times 1 minus tan x. What does that equal to?
It'd be tan squared.
Hold it. Start with that.
Oh.
Go left to right whenever you're foiling.
So it's 1 minus 2 tan x minus
plus
2 plus what?
Reason it's plus is let's look at it.
Oh, yeah. Yeah.
That times that 1. That
Yeah.
times that is minus tan. That times that's minus tan. So you have minus 2 tan. That times that is plus tan squared x.
All right.
Okay. And now the problem is basically solved, as all you have to do is put those two things together.
All right.
There's an identity that says 1 plus tan squared is equal to secant squared. So that's what the left side becomes.
All right.
Still a little harder.
No, wait. No, I don't think so. Yeah, I mean, I don't think it's all.
What do you think our first step should be here?
To foil out.
Almost always. Almost always. In other words, you might have said, well, let's turn everything into sines and cosines. Because we got nothing but cosines over here, we can turn this into sine over cosine. That could be a first step. But whenever you have 1 minus sine or 1 plus sine multiplied together, what does this become and why is it so beautiful to multiply it together?
It just becomes 1 minus cosine squared.
Right. In other words, that's difference of perfect squares, factored.
Yep.
Right? And this was the difference of perfect squares, unfactored. So whenever you see difference of perfect squares factored, it's nice to recognize it because it makes it really easy to FOIL it back together again. Okay? So what is 1 minus cosine squared equal to?
It'd be, isn't it just sine squared?
Yeah, that's what I was saying. Look for 1 minus cosine squared or look for 1 minus sine squared. In other words, whenever you can take two terms and turn it into one term, that's almost always the way to go. Notice that in the original problem we had 4 terms. We turned 4 terms into one term right there. So the whole name of this game is to reduce, reduce, reduce. In other words, if I can turn 2 terms into one term, that's almost always the way to go. Sine squared over cosine squared is tangent squared.
All right.
Now in my book, as you go up, they get a lot harder. But that's okay. There's nothing wrong with degree of difficulty because they're all testing the same thing. They're testing, make sure you know your identities.
So I was actually going to do an IT cost process review right after the conversation.
We got a cosine, we got a cosine. That can be turned into sines and cosines. That can be turned into sines and cosines. Right off the get-go, that would be the way I would proceed, merely because I don't see any other way to proceed.
All right.
Okay, so let's make it cosine squared over sine squared minus cosine squared. And now we have, what are we going to do with that?
Common denominator?
Yes, that's the key. You almost always want to find a common denominator, which is sine squared. What's in the top?
It would be cosine squared minus sine squared cosine squared.
Uh-huh. Okay, now what's the next logical step there?
Wouldn't it just be...
Factor.
Yeah, factor.
Because notice what you're going to have left after you factor. You're going to have 1 minus sine squared. That's 2 terms that can be turned into one term.
Yep.
Okay, so I got cosine squared. What's left?
Isn't it just sine?
1
Or is it 1?
minus sine squared.
All right.
All over sine squared. Okay. Well, 1 minus sine squared is what?
Cosine.
So we have this over that. Cosine over sine is what?
Cotangent.
Cotangent squared times cosine squared. That was the original right side. Cotangent squared, cosine squared. This was a little harder. This one had like 6 steps to it, or 5 steps. Okay. Yeah, I went through number 26 in my book, but I'm in chapter 5, so I'm pretty sure my book is not the same as your book if you're in early chapters. Your book must be specifically Trig, or is it a combination of Trig and Precalc?
It's specifically Trig.
Ah, interesting. Okay. Mine is combination. So, all right. I think you understand basically what the goal is on these, and remember that if all else fails, turn everything into sines and cosines. That won't always work, but it works a lot.
All right.
Okay? All right, Mitch. I'll talk to you next week.
All right.
Bye-bye.